Hello there, I'm Thomas, the pilot captain flying the Airbus A340 313X in this flight from Zurich International Airport. I'm going to be flying back to Zurich International Airport, flying through a few waypoints, overflying Switzerland and Germany, and then come back to the Zurich airport around runway 14. So right now I'm in the cockpit for the pre-takeoff preparation. I'm gonna make an engine start demonstration and set up the flight management guidance computer for with the flight plan and the fuel level of the aircraft, fuel balance and weight of the aircraft. And so we're gonna make all the calculations for setting up a flight plan and the takeoff speeds using the flight management guidance computer, which is gonna guide the autopilot flight director system that I'm gonna show you later. I'm gonna be showing you also the displays, the primary flight display, the flight mode annunciator, the navigation display, the ECAM, the upper ECAM and the lower ECAM, electronic supervised aircraft monitoring. I'm gonna show you the thrust levers and the engines control. I'm gonna show you the trimmable horizontal stabilizer THS, which is connected to the auto thrust and auto trim system, and the flight management computer and autopilot. So I'm also going to be showing you some of the systems of the overhead panel, like the fuel, the hydraulic, the electrical alternate current, direct current, the batteries, the air system, the compressed air generators like the engine and APU compressed air sources that we use in the air panel for the air conditioning, the cabin pressurization, for the hydraulics pressurization, and some other systems perhaps like the RDIs. And I'm going to show you also the air data inertial reference system, the ADIRU, which generates a GPS and accelerometer and also gyroscopic acceleration and barometric and anemometric data for the aircraft. And this displays this information in the primary flight display and the flight mode annunciator and the navigation display, and also the flight management guidance computer for using it for navigation of the aircraft. So I'm also going to be showing you the flight controls, the side sticks. So let me start now. I'm going to be talking to you about the fly-by-wire system of the Airbus A340 aircraft and how to use the side sticks and the trimmable horizontal stabilizer manually or automatically for balancing the aircraft in flight. So let me start right now. As you can see, we are in the aircraft. We have we have the displays here. You can see we have the side stick here in the left. As we can see, I move the side stick up and down, and the side stick moves also left and right. You can see also this displayed in the primary flight display over here, which displays various information like the aircraft guidance, the flight director, and the side stick position. When the pilot moves the side stick to control the flight controls like the elevator up and down, and the ailerons and spoilers left and right, and also the rudder left and right for the yaw turning, the rudder pedals. So you can see also the airspeed display, minimum airspeed right now. You can see the barometric altitude above sea level for this QNH, for this barometric pressure 29.92 inches or 1013 hectopascals, 101,000 hectopascals. So I think it's 101.300 hectopascals. So here we have the flight mode annunciator. We have the airspeed displayed, the airspeed selected right now from the autopilot display with blue right now here. So you can see it's 100 knots. We also have one flight director too. If we move the thrust levers, for instance, all the way up, you're gonna see here the manual takeoff go around, which is manual mode of the auto thrust, and the auto thrust in blue. If we move them down to flex and CT, we have auto thrust in blue again. If we move them in climb, we have auto thrust in white, which is active. So if we move the thrust levers down to the idle, the auto thrust disconnects. So we have active auto thrust all the way up from the climb down to the forward idle, and we disconnect that idle. But we need first, before setting to the climb, to arm the auto thrust and takeoff go around flex. If we are in the ground, if we are in flight, it's a little bit different. So here we are in the runway. You can see I'm having here the side sticks I have been telling you about, which I can move up and down, left and right. So you can also see I'm using this side stick to fly the aircraft, the Lszh Extreme 3D. Hope you can see that. So maybe the lighting is not so good. So you can see I'm using this side stick to move the elevator up and down, 30 degrees up, 15 degrees down. We have the limits, and bang roll 67 degrees either way, without auto coordination or auto trim, and 33 degrees up with auto trim by releasing the side stick. So if we move the side stick 33 degrees either way in flight, without the autopilot, the auto coordination, the auto trim is gonna trim the aircraft for maintaining a Z-limit request, at Z-limit acceleration in flight. So if we bang roll higher, maximum 67 degrees in normal low, we'll need to maintain the side stick in position. 67 degrees, like 2.5 G's if I remember well. So 2.5 G's turn, you have to maintain the side stick. 33 degrees, you can release it, but the bang roll will be maintained automatically. If you do that with the side stick at 67 degrees and then release it, the aircraft will return back to 33 degrees bang roll. So there is also two limits, 30 degrees up and 15 degrees down, for pitch up or pitch down of the aircraft. So this is about the angle of attack of the aircraft. So you can see here, it's not a thing about the elevator position. So I'm also going to be showing you here, you can see the displays. Maybe we need a little bit more lighting here, make them a little bit brighter, display better. So I'm not sure if you can see better like that. Perhaps a little bit more crisp view. So you can see here the flight controls I have been telling you about the side stick. So we have another 60 minutes left for this flight. So you can see the flight controls displayed here in the ECAM. Lower ECAM displays various systems. So you can see the yellow, green, green, blue, yellow, green for the ailerons, the rudder, green, blue, yellow, and the elevator, blue and green yellow for the right elevator and blue and green for the left. So this is the hydraulic source for actuating the hydraulic flight controls, which are most of them except from the rudder. They're all electrically controlled but hydraulically actuated. And we have the hydraulic fluid system here. Green, blue, yellow, and green. Engine 1, engine 2, engine 3, and engine 4. We have four hydraulic sources right now to supply the flight controls over here, the nose wheel, the rudder pedals, the rudder control. When we move the side stick, it's electrically controlled, but the surfaces here, I'll show you the elevator and the other one, maybe you can see they are hydraulically actuated but electrically controlled, except from the rudder. The elevator, the pitch stream of the trimmable horizontal stabilizer where the elevator is located, and the other ones and the spoilers are also electrically controlled but hydraulically actuated. So you can see that here, moving this side stick, I don't know, up and down, you're not going to see this happening for this reason. Moving up and down the elevator, and the other ones and spoilers left and right. So we have the flight controls movement. I believe this is so much for the flight controls. You can also see some of the flight controls here. Also here the spoilers. So we go back into the cockpit. We need right now show you in the overhead panel a few systems. We can use here the wing and the engine 1, 2, 3, 4 anti-ice system, the wing anti-ice, and the probe heat for the pitot, static, and anemometric and barometric data. So here we have the auxiliary power unit. We're gonna start this. We're gonna start the master switch here. So maybe if I'm gonna show you another view of the overhead panel, coming here in the jump seat. So here we have another view of the cockpit. We have like 67 minutes remaining. So here we have the overhead panel. As you can see, all the systems displayed. This is the Airbus A340 cockpit. So you have the thrust levers. You can see when we move the thrust levers all the way up to a position, the takeoff go around. We have the displays here, the takeoff go around, and here in the primary flight display also. So we move them down to the aisle. We have the pitch stream wheel. We use this for the tail of the aircraft to control the balance. So here we have the speed brakes. We have the flap lever position, flaps and slots position. We have the radio communications. We have the radar here. You can turn on the radar system here for display. You can also use the switch. We have the transponder here. Integrity light. Integrity light maybe. Oh, we have a little bit more light here in the systems here. So we can use the radar. You can see the radar here. The tilt of the radar, the gain of the radar. So we can move this to the maximum and use this for the map display and change the tilt. You can see the speed brakes here, the flaps position. We have the rudder trim here. You can use the trim and then reset the trim to 0 position. We have the transponder code here. You can move this, or we have it ready actually. Traffic advisory and resolution advisory. So here we come for this display now. The ECAM that I have been telling you. We have another 65 minutes left for this video, so we can see what it displays here, also here in the expand view. So we can come here in the overhead panel systems. I will show you here. We have the APU. You can see the APU. We can turn the master switch on. You will see the reconfiguration happening here. You can see the flap now. The computer is start controlling the APU for start. So this small air turbine and electrical turbine to use for engine start in the ground or in flight for emergency if we have engine failures, loss of electrical and hydraulic. So you can see the bleed here and the APU generator volts and hertz in alternating current, how much it will produce when it's gonna be rolling. So I'm gonna try to be very fast with this. Have 23%, 24%, 880 degrees exhaust gas temperature. So you have also other systems like the hydraulics here, the engines, fire control, the fuel panel. We have the fuel pumps, we have the electrical here, we have the air systems here. I will be showing you everything, and the air compressor from the engine. So here we have the APU now start. We have it ready. So this is the APU generator, 116 volts, 400 hertz. The bleed PSI can be turned on now. You can use this over here. This is the bleeder from the APU. Here's the APU bleed, this switch. Turn this on and you see here the arrow displays is on. If we turn this off, you see the arrow is cross. It's cross parallel. Now it's cross horizontally. Now it's on and supplying with her compressor. It is available. So we use this to start the engines. So we go now in the cabin pressurization panel. Maybe actually first the bleed system. You will have the bleeder from either engine 1, 2, 3 and 4. As you see here the engines in front of you, the thrust levers, we have 4 engines, 1, 2, 3, 4. 1, 2, 3, 4 engine bleed sources. So this is the high pressure and the intermediate pressure, the HP and the IP. The HP, the high pressure is the 9th stage of the turbofan for this aircraft, CFM56. The intermediate IP, it's the medium pressure from the 5th stage of the blades. The one blade stage behind the other, it has, I think, like must be like 12 stages or something. So this is the high pressure compressor, this is the low pressure compressor, I think. So it supplies when it's on. We have to turn off the APU to show you how much pressure. We turn the APU bleed and we have the engines on. Now the engines supplying with compressed air, as you can see, 50 psi higher than the APU. The APU is only 14 psi. So it's quite a lot of pressurized air. If we increase the engine thrust, maybe we'll have more air pressure, I'm not sure. I think it's regulated. We have higher temperature actually. You see the temperature rising now. This hot air from the engine. So this is good simulation for this aircraft. You can see how much hot air we have now from the engine. So I will come over here. You can see also here is the packs, the left and right pack, which supplies the ADIs with hot air, and the cabin pressurization compressor, and the hydraulic system, fluid tanks with compressor. So we'll use the APU is gonna close here. The APU switch is gonna cross in and close the left and right engines supply. And this is done not to have reverse air inside the engine. So we now go into the electrical, maybe go into the cabin pressurization panel. I will be showing you here. Here we have the cabin pressurization of the Airbus A340. You can see the small panel here, small section. It says mode select, vertical speed control. You can use this mode select. You have the landing altitude, elevation. You can use manually, and the ditching for landing into the sea. For not depressurizing the cabin in case you land in the water. So you have the mode selected. You have it automatically now. The light is off. You can use manual. You can see light is on now. Manual mode. So we control now the cabin manually. If we climb, we use this in the up position, and you will see now the arrow here, the vertical speed feet per minute going to 100. If we do it one more time, 1, 2, 3. I think we have to repeat this in order to, yeah, we have now 200. It's increasing higher, the rate of climb. So it's 1,500 feet. The cabin is a little bit higher than the aircraft now. It's climbing. So we can use this in the down position. We can decrease it to 0. Now it's in the level of the aircraft. Now it's going down below. It's pressurizing the cabin. It's coming where the aircraft level is. So we'll use the auto mode now. We have the manual here display. We have the valves here, the inlet and the extract. This is to control the outflow of the compressed air from the cabin. The outflow, the inflow, when we climb, we close this, we move this in the up, and when we descend, we move this down, we open. So we have the PAX supply compressor and the safety valve here. So we use back to this system 2 in the auto climb mode. The landing elevation is right now in the 0, I think. It should be in the auto. We'll set up the flight plan, we'll select the elevation. So we go back into the electrical panel. We have another maybe 58 minutes for this flight. We have the electrical alternate current, the left engine and the right engine electrical alternate current. So we have from its generator on integrated drive generator connected in a small section outside the engine and connected with a shaft through a belt, I think. So we have the contactors here which and the disconnect, the IDG discarded switches. We should not use them. So we have the offer set. We'll close these. 1, 2, 3, 4. We're gonna lose the generators from the engine, the alternate current. So you can see now the generators are off. If we turn off the APU, now we have the APU supplying 160 volts, 400 Hz, 89% load, and the external BNA available. So this is 75,000 kilovolts or 75,000 watts of electrical alternate current. We can disconnect the APU. We will see we lose all the systems except from the PFT, the primary flight display here, and the ECAM display, the upper ECAM. So we have no alternate current normal sources, and you see here the messages, the fault messages: electrical DC bus 1, bus 2 fault, electrical AC bus 2 fault, electrical AC bus 1 fault. So we can very quickly here on the overhead panel, if we reconnect this switch, the APU here, you will see the electrical is coming back alive. If we disconnect it here, the APU generator, you can see the lights go off for some displays and some system. So we have the aircraft in a different configuration like that. Perhaps we'll use some flight computers for the autopilot, I'm not sure. But we have no messages for the autopilot, so it must fly in the normal load. So we reconnect the APU, we reconnect and the engine generator contactors. So we have them all set up normally. So you can see it's engine, we have 4 engines. Generator 1 for the left wing, engine 1 and engine 2, and generator 2 here for the right wing engines, engine number 3 and engine number 4. We have 75,000 kilovolts each engine. For engine it's 300,000 kilovolts or 300,000 watt, 150 volts each one, 399 Hz. The IDG oil temperature 124 degrees, and you can see the sources. This alternate current can be converted into direct current through the AC1 or AC2 alternate current transformer rectifiers through the AC1 bus or AC bus 2. So you can see here in the direct current the direct current page. We have the transformer rectifier 1 and 2 supplying 28 volts, 49 or 40 amperes of current into the batteries or the APU batteries for charging. You can see the batteries are connected right now. So here we have the batteries. We have now the direct current. You can see also here in this diagram, these arrows, the configuration of the electrical path, the path of the electric current. So it goes also backwards from direct current to alternate current through the static inverter. If we lose all the electrical, the alternate current again, we have the static inverter reconfiguration. That's not displayed here. So we have battery 1 and battery 2. If we disconnect them, we can disconnect them, the APU, the auxiliary power unit battery. We have the off messages now. All batteries off now. So we have like 53 minutes remaining. Reconnect the batteries very quickly. Come over here in the hydraulics page now. I will show you. We have another nice view here of the aircraft, Airbus A340. Side view of the Switzerland. We have a few minutes remaining for this flight. So we come over here very quickly on the overhead panel. Use the ECAM lower display again. We have the systems here, the hydraulics. So you can see we have the green, the blue, yellow and green again here, this panel. So we have engine 1 has the green hydraulic pump, supplies the green hydraulic pump, drives it. The engine number 4 also drives the green. Engine number 1, engine number 4 is the green hydraulic system, and number 2 is the blue hydraulic system. Engine number 3 is the yellow electric system, which is also displayed here in the flight controls, for instance, or the landing gear and nose wheel steering. So this is used primarily for the flight controls, the flaps, the slats, the landing gear, the rudder pedals, the ailerons, the elevators and the THS. We can move this wheel, the THS, the elevator moving here. You can see the rudder green, blue, yellow. We have green, blue, yellow, and the elevator blue, green is the left wing engine, green, yellow is the right elevator, and it's crossed for the ailerons. So it's yellow, green and yellow, green for either green, blue. So it's because it's inboard and outboard ailerons. So here you can see the rudder pedals we move. This is also using the hydraulic sources for the rudder, for the tail of the aircraft. So we come here back into the hydraulics page, and I'll show you very quickly. Coming up here. So if we disconnect either one, the engine 1, you can see here, discarded switch. Engine 1, disconnect. Engine 2, the blue, the green, the blue, the yellow. Engine 3 and engine 4, the green again. We're gonna lose all the hydraulic power from either engine. We have 50 minutes left. We have to do very fast. So we can see the hydraulic pressure going down. It will come down to yellow, to 0 eventually, if we let this go. So we're gonna lose the flight controls. You can see here now the flight controls, the configuration we have now. We do have pitch stream. We still have mechanical pitch stream through cables. The rudder is not moving, the ailerons and the spoiler is not moving. So we lose all our engine, we lose all hydraulic sources like that. With the pumps you can see now 0 psi from 3000, and everything displayed with yellow. So if we reconnect here the electrical, displays with blue now here. The green, the blue and the yellow. So you can see we have back the hydraulic pressure. So we have back the hydraulic in the flight controls. You can use this as a standby. So we have back the standby flight controls. You can see the rudder is moving, the rudder pedals. We move the rudder. We also have the electrical pitch string here, and the ailerons and the spoilers. And the elevator is moving. So we can use this configuration instead of the engines, but we reconnect the engines to hydraulic pumps. Here we have the engine fire switches. We have some other systems maybe. We have the flight. We have the air data inertia reference system, which has 3 IRSs with GPSs, and also it has gyroscopic acceleration and pulsation, and barometric and anemometric and uncoupled attack data, and some other data. Maybe I'm not sure. I don't remember quite well. Also, I think it's VOR navigation also. VOR and waypoint navigation, and this is displayed here in the primary flight display. In the navigation display, you can see the airports around us. If we increase the range, we have the airports in the GPS. This is displayed from this source over here. These 3 air data inertia reference system controllers. This display. So here we have some other controls. Here we have the flight control computers. We have the primary one, the secondary one, flight control computers. Here we have the fuel. We can split also the fuel tank now, the fuel tanks. We can split the inner tank in 2 sections with that. So here we have the jettison. We can arm the jettison and dump the fuel. We have the active mode. Here we have the secondary flight control computers, and second 2 and the primary 2 and the primary 3. And also we have some other switches like the manual engine start. Here we can move these switches and use manual engine starting. These are guarded. What we're gonna make automatic for this flight. So I'm gonna show you now the last part of the overhead for this section, the fuel panel. So we have the 46 minutes, the primary and the standby fuel pumps. We can turn off the fuel pumps. We're gonna keep having fuel into the engine through the standby here. We have 4 engines, so 4 fuel sources here. You can see engine 1, engine 2, engine 3, and engine 4 as it goes with the other systems. This also has we have the fuel used per engine right now, total, and for each engine separately, 1,440 and 5,070. We have 30,000 pounds of fuel in each wing, in air tank, and 1,900 in the outer tank. 10 pounds in the center tank is empty, and 3,300 in the tail section of the aircraft, in the trim tank. So we have 68,200 pounds total. The APU now is running, is taking fuel. You can see this arrow. So you can see the temperature of the fuel. So we'll fix these fuel pumps now. I will show you. We also have the X-feed. We can turn the X-feed valves here on. With this, any pump supplies any engine. So this is for the engine feed, engine 1, engine 2, engine 3 here, X-feed 3, and engine 4 is X-feed 4. So we have the primary pumps. We're gonna turn them on again, turn off the lights, the white lights, and show you a couple more things, and then the engine start demonstration. So here we have the XFR from the center tank, from this section into the inner tank. We can do it manually if we want, but we have the fault message. There is no fuel into the tanks right now, to the center tank, so there is no transfer. Turn off again to the automatic, no transfer. Turn on manually, fault So you can see that we cannot transfer fuel from the center to the inner tank because there is no fuel. Here is the mode from the aft tank to the forward transfer. You can do it manually or automatically. We also have here the other tank transfer. You press this button and it will start having this arrow transfer fuel from the other. But we're gonna leave them like that. Close the switch. So I'll come here now very quickly. So you're gonna use these switches, the engine master switches, which control the fuel low and high pressure fuel valves here, except from the XV. This is the vertical, the low and the high pressure fuel valves. So we're gonna turn them off to turn off the engines, and then we're gonna use this switch and master switch. So we come here very quickly. We have 43 minutes left for this flight. We're still having to start the engine. We have this, we need this view, we need the virtual cockpit. So we will have it for the virtual cockpit. We're gonna use this here. We have this in the auto, but we can close it and also use the closed position. This is gonna turn off the pack 1. You can also turn off the packs for starting the engine. You can turn the packs off, we turn them on later. So we come over here, turn off the engine 1, 2 and 3 and 4 master switches. This is gonna turn off fuel flow. You can see here in the levers, now we have better view of the position of the center of gravity trim, which is 0 right now. You can go up to 2.5 degrees and climb the dentants of the thrust levers. So if we move the thrust levers, now we're gonna have no engine thrust, engine power. So you can see the engines are off right now. Here the fuel valves are off. We have the engine reconfiguration pins here. You can see that. So if we come out here, I'll show you the front of the aircraft. You can see the engines are off right now. I have to come very quickly and turn them on. The engine is slowing down, still some spinning. So you can see the engine stopped spinning now. So we can use this master switch into the ignition start, starting the left engine first. The left wing engine 1 and 4, 1 and 2, excuse me. So this is armed now to the start mode. If we start the engine master switches 1 and 2, we're gonna see here we have a reconfiguration and we have the initiation of the admission of the compressed air. We have the FADEC controlling this automatically. The start of the engine when the fuel flow reaches maximum, when the N2 reaches 20% and higher. So you can see here we have the engine start spinning left and then here we have them in the available. So here we go again. We have 40 minutes left, so we turn the packs the left and the right on, and this in the auto, the isolation valve for the air bleed system. So now we start the right wing engine number 3 and engine number 4. So you will see here the N2 and the N1 is increasing. When the N2 reaches 20% or higher, the fuel flow will go from 200 to 2000 pounds per engine per hour for the right wing engine. So you're gonna see here the right wing engine starts. we have this configuration, and the engines are also started. This wing and the left wing. So we have all the engines started. Now we can start. We can set the flaps here in position 2. Everything in the overhead panel is normal. There is no message, so we can set up the flight management computer very quickly. We have 39 minutes left. So we have the fuel prediction here. Fuel on board 67,600. Gross weight maybe 394,000. 394, excuse me, 1,000 pounds. Gross weight. We have a fuel on board here. Initialize here from Lszh to Lszh. This is going to be used for takeoff and for flying speeds, the gross weight and the fuel on board, and for distance calculation, how much flight time we have with this configuration. So the cruising altitude for this flight 25,000 feet or higher, minus 35 degrees, and the Cosydix 100. We have fuel prediction again, 394. We can see the cruising temperature, maximum cruise altitude 36,000, like that, with this weight and this fuel, minus 35 degrees. So we go into the flight plan from Lszh. You can see from Zurich International Airport, departure. You can see the position, the GPS position here of the runway in the airport. So departure runway 14, 3,300 meter, ILS 108,300, 137 degrees direction of the ILS heading. So we use this trans Zui to Alpha. So we insert this here, insert, and we have half of the flight plan now over here created. So we have here, show you closer, turn on the ILS, use this maybe view, is better, the FS control panel. So we have half of the flight plan here to the Zui. So we also have some moves around here for takeoff that we're gonna see. We have the ILS here ready. We only need that set the heading here like that. So maybe I increase the range a little bit to the 40. So we come down here, intercept, Lszh, arrival. You can see the GPS position again here, and the arrival, ILS 14,300 meters, ILS 108,300. So same ILS in runway. Trans, degree 1 alpha, insert. So we have the intercept, clear the discontinuity here on flight path. So here we have the whole flight plan for this flight. We're gonna take off and then turn left and back and then fly over here to this waypoint. So if we turn the engines now in the takeoff go-around position, you're gonna see we have some reconfigurations again. We still need to set up one last thing, so intercept. So you can see arrival from progress performance. So we have flaps 2 and 2.5 degrees up the THS horizontal stabilizer, the horizontal tail of the aircraft. So minus 12 degrees for takeoff. We have the one, it should be calculated automatically, but we use manual inputs. 145 rather Daxon 2900, 150 and 155 for this flight. We have 34 minutes remaining, so we only use this to balance the aircraft. So we have the flight controls here. You can see the THS position is 0. It agrees with that with the trim wheel. position, 0.5 up. So we're gonna use we'll trim it up a little bit. Hope you can see trim wheel. I trim up using this we'll trim it up like that, 2.5 degrees up. This is the center of gravity position as a main aerodynamic chord ratio of the wing. So here we have the tendons of the thrust levers. I think we are almost ready for this. We have 2.6, 2.5 minutes. So you only need to use this higher altitude here. In the autopilot, this is the autopilot flight control unit, so you can see the heading, the airspeed, the heading, the altitude, the autopilot 1 and 2, the localizer, and the auto thrust. So if I move the thrust levers now all the way up, you will gonna see the auto thrust in green here is armed, and so also some reconfigurations for takeoff. You see the manual takeoff go around here in the primary flight display. You can see the SRS, the runway, the nav, the one flight director, the auto thrust in blue, 35,200, 145, 155 is the takeoff speed, 145 is the V1, 150 V rotate. So we have here, you can move this back down, you can move this, you can see the flex also. We have the flex temperature, we have the climb here, the auto thrust now is on. So you can see the ILS frequency here, the ITL is automatically set, the radio management panel. You can see this diamond to represent the heading of the runway in this cross. So we have the altitude here, we have the side stick position, so we maintain done until 100 knots, but halfway done to compress the rudder, the nose wheel thing down using the elevator. So I hope you can see that how clear it is now looking. We have another 32 minutes for this flight, so we come here, we're gonna take off now. This is another look of the runway, the aircraft, very 114, ready to take off, 31 minutes. So we move the thrust levers to the takeoff go around position. You will see the engine thrust increasing and the mode here, the takeoff go around. We are ready to take off. We have here the modes, manual takeoff, SRS and runway, engaged in green, and the climb and the nav for the flight control and the autopilot to reach the altitude 25,200 feet, and the ILS, the glide slope and the localizer. So here we go, we disarm, we move the side stick down and disarm the parking brakes until 100 knots, then after 100 knots we move the side stick up and we release it. So we go 67, 75, 80, 85, 90 knots, 100 knots, here we are. So you can see as we move to the runway, we have 130 knots, we have V1, V rotate, and V2. Here we go. You can see on that side view here, as we climb. Probably too much of the climb. Have to level off a little bit. So here we go. We track the landing gear up, and you can see also an outside view, a better outside view as we keep climbing up here. And I'll show you farther right now. We have another 20 minutes to go for this flight. So we keep climbing out. You can see the modes here. We have the I'll level off for a while. We have the stall speed here, 120 knots. This is the VLS actually for this aircraft. We have the rate of climb. We have the radio altitude here, 2,200 feet above the ground level. You can see that hopefully. 2,300 feet, 340 feet. This is the distance above the ground using the radio altimeter. This is the flap position. I will move the flaps up now. So this is the rate of climb, 1,400 feet, and the altitude above the sea level, 4,000. So the airspeed is increasing. We need to retract the flaps a little bit. This is the flaps lever. Use this to retract the flaps. This is the pitch spring, the automatic pitch spring here. So we keep climbing here. 20 minutes to go. Make a turn. You can see the thrust asking us what the thrust is, and to move the levers here in the climb position. This then over here. So we have now the auto thrust and blue is engaged for this climb. We move into the next waypoint now. Let's see how we fly manually in this. I will show you the limits here, later of the turn. I will take a turn using the auto thrust and the fly by wire system, the limits. So we need to make a turn now over the flight path. So here we go. We have the arc mode now engaged for this display. We have the runway actually here displayed, and the waypoint is 6.8 nautical miles away from us. So we keep climbing like that, 2,400 feet per minute. We're gonna need like 10 minutes. We use a higher rate, like 2,500 maybe feet. You can see how I move the side stick, climbs or descents. So here we have another nice outside view. The Airbus A340 with the Zurich as we climb out. Hope you like this view. The Airbus A340 A313X. It's a very cool simulation actually. Having the other side maybe pointing. Keep climbing out, 11,000 feet. We have flaps here, we have the auto trim. You can see it's moving the trim up or down. We have the flight controls here, the elevator all moving because we fly manually right now. We have no autopilot connected. You can see the altitude here. The heading is automatic because we press in. If we press this out, pull out, we have a manual selection of the heading or at the altitude or the vertical speed. So we can use a higher vertical speed here, 1,000, 2,500. Okay, this is flight control autopilot unit. You can see autopilot 1, 2, and auto thrust localizer, the approach and the expedite also. So use a higher airspeed maybe, like 230, 240, 250 knots maybe. You can see how we climb out here. Going to the next waypoint, trans 14,000. We have the MCP now set because we select this template. We have the climb now set. the speed is on, the vertical speed, the knob, the auto thrust is active. So the thrust now is decreased to 89%, 92%, and to fuel flow 7,020 pounds per engine per hour. You can also see the fuel on board still, the ignition. We have continuous ignition here. If I show you here, we have the bleed from the engines and the FPU. Now we have the FPU, and here we have cabin pressurization, which is normal. It's 2,400 feet. The aircraft is should be climbing actually. The PSI differential pressure between outside and inside the cabin is 5.9 PSI. So climbing, we need to use this to the manual takeoff go around. Is more thrust actually for this climb, and maybe level off a little bit. Okay, we climb back. Let's see. Have a nice view now of Germany here. This way is money. But we still will find Switzerland actually. So here we are, 18,000 feet above ground level. Another nice view maybe. Still not having the chemtrails. 32 minutes left for this flight, so we have to be moving a little bit faster than that, to return faster into the airport perhaps. Now we are flying the lake here. Huge lake. Nice view. So we keep climbing 21,000 feet now. The entrance again. Here we are closer to the waypoint. We have this cabin set. Now we are higher, maybe 7.3, still the same. So we have the bleed, the electrical, you can see it's normal from the engine. The direct steering is normal also. The hydraulics, the direct steering is normal, and the fuel is normal. So we're gonna use the flight control page instead now. As we climb out the first waypoint, maybe show you a little bit more distance farther away. So we need another 20 minutes for this flight. We almost made it. You can see the modes here are they are 23,900 feet above the ground. We need to level off a little bit to accelerate. Maybe we track the flaps in a while. We have the flaps at S here position. You can see also displayed here in the navigation display, also in the ECAM axis. So we are 24,300 feet above the ground level. Keep climbing. So here we have the chemtrails now. Beautiful chemtrails. Keep climbing up. We have these vapors from the engines. So So we have to level off in a while. Going back into the cockpit view again, so you can see we have we almost reached the climb altitude, so we're gonna move the thrust levers to the climb now. So we have the speed arm, the auto thrust arm. You can see here. We're gonna move back into the airport now. Maybe fly for a while, for a minute, maybe feel like that. And going back into the airport. So here we are. We have the altitude arm now. We are at 25,000 feet. Maybe we'll arm the autopilot later for a minute or two. So here we are, 35,000 feet above the ground level for the Airbus A340 313X. So we're flying Germany now. The Bavarian Alps region in a while. We can pass Switzerland. $35,000 feet, flight level 250. So maybe we should start going back now. I have another 17 minutes left. I'm gonna start turning back into the airport. Nice lovely leaves here. The entrance. Okay. So we go back now to the airport. I will start turn. Trying to hold level. Maybe track the flaps now. Because it makes harder to hold a position here. Even now again. So there's more of distance here where we are. Let's see how far away we can see here as we turn. And this is how we maintain a bank roll here in this altitude with this airspeed. Using the fly-by-wire system manually, like that. We request a zero acceleration for this airspeed and altitude. So right now we are about maybe 30 degrees bank roll. So we can release the side stick like that. This fly-by-wire mode of the Airbus. So if we keep turning like 67 degrees, we have to keep making the input, otherwise the fly-by-wire should turn us back into this position. So we have like 15 minutes left maybe. So we need to get back into the airport very quickly. Maybe I will show you how to use the autopilot now. So you can see the modes here, the flight level we hold. They're nice views here. I will keep turning. 15 minutes left. Nice views here in this flight level. This is a better view of the Airbus A340 until now. Minutes left. I have to be very quick now. soon you can see our spacecraft now. We're flying this flight out looking these chemtrails on the galaxy. It's 7,000 feet, leveling down now, going lower actually. Maybe use the autopilot mode now just to show you how to connect the autopilot. So we turn this green switch here. We turn this off to on, the autopilot 1 or autopilot 2, whichever we like, so it's active. So maybe we have to turn the others off. Now confuse the autopilot with the other system. So we're going back into the airport with maximum airspeed max 0.745 right now as we level off. So you can see autopilot 1 here. 13 minutes left, so we need a maximum airspeed. Maybe use a direct 2 to the next waypoint. Please. Here we have it, flying direct 2 into the waypoint. And we have 45 nautical miles away. Maybe we're gonna start descending in a while. 12 minutes left. So here we go. Still 12 minutes left. You can see the flight level here. Beautiful chemtrails. See galaxy here displayed. Now we are overflying the lake again over Switzerland. So we come back again into the nice view. Lake. With just 36 nautical miles away, we start descent now. When you see it descend, now minus. Go to the minus now. So we descend 7,000 maybe. This is maybe the expedite, I'm not sure. And it's 2,300 feet per minute. You can see the autopilot is still on. So we have the reconfiguration. We're gonna slow down maybe. I use some speed brakes here. This lever. The speed brakes for the sun. You can see them displayed here. So we have 10 minutes left for this flight. Crossing 23,900 feet. Maybe use. We have vertical speed arm. You can see how we descend. Maybe decrease the airspeed a little bit. No more manageable. Shear level, we have still the autopilot on. You can see as we descend. 10 minutes left. Left, 17,000. You coming closer. Use the localizer here also for this approach. Using the approach mode, maybe the performance, descent, next phase, QNH speed 9.92, temperature minus 12, 168, 163, 10 knots, and season height 100. So here we are descending 12,000 feet now. We have like 8 minutes left. We have the modes here. Maybe slowing down a little bit more. For more manageable airspeed. I think we need to disconnect the autopilot now. This tries to align us with the runway. It's not correct right now. Keep descending. Flying manually now. Using this RAS 8 minutes. I use some flaps now. Making this approach now through the decrease even further the airspeed. Use the Lszh localizer also. The Lszh is on, so keep descending. For this approach we're still a little bit higher, 9,000 feet. We need to extend the flight path a little bit and slow down. We are overflying the runway. We have time remaining 7 minutes. Keep descending. So we track the speed brakes and use flaps maybe to full. I'm not sure. Time remaining 6 minutes. So we're going without the autopilot, only the auto thrust, and decrease this speed also. Plus maybe 155 knots. After this approach, keep descending. Six minutes left. We're overflying the river again. Maybe we're gonna use the landing gear now. Over here, retract, extend the landing gear. Maybe use some auto brakes, the medium. So we keep descending. We just need to align with the runway now. We are in a good position except the headings. So to maintain this stern balance, we have the auto thrust on. We have some clouds now, beautiful. As we descend, you can see we have a better view here. We have the runway. Try to keep a little bit higher. We have the landing gear down, so we can see the landing gear here now has been extended as we descend. So maybe use this view for landing. We need only to align now. With the runway we have like 4 minutes left. Oh, now we are in a very good position. Here we are. Maybe use the landing lights on. Not sure. We have 4 minutes left. Disarm the thrust levers. The other thrust. This is going down now. So we can see here we have 3 minutes left. We have the Ilsloc localizer here. The glide slope is on, and the heading is on, and the radio altitude again. So we keep descending. We are a little bit higher. Doesn't really matter. We need only to align. 3 minutes left. This is an excellent flight here, as you can see. As we try only to align, we have a good flight path. 2 minutes left. For this video to end. $500. So here we are. As we descend, here we are. And touch down the runway. We have the parking brake, the auto brakes on, reverse thrust, maximum reverse thrust, and parking auto brakes. Sorry. So we slow down into the runway. We have a good, very good landing. Manual landing here.